This is the hydrate lab that I was telling you about, the one where we are going to take a crystal and boil off the water and be left with just the crystal without the water attached. The crystal we're going to use today is copper sulfate hydrate. They're not telling us how many waters because that's the point of this lab, figuring out how many waters are attached. This copper sulfate is used for a lot of things. It's a fungicide, it's used in paints, and the color is really pretty. It's a bright blue. So this is the lab setup. Let's look at the lab setup. So we are going to take. Let's start. Let's read this. Let's. Okay. So here's the amount that we're starting with, and we're going to heat it up in an evaporating dish in a Bunsen burner, and it's kind of blue when you start, and you're going to heat it until it totally turns white. Okay. And look at the way the color changes, and like the color changes, it keeps changing and changing and changing as time goes on. And what you want is for the final mass to be stable, and when it's been stable for a while, I can stop. So I know the initial mass. What's the initial mass is for the mass of the copper sulfate and the waters. And notice the way they put an X there, because we don't know how many waters. That's why we're doing this lab. And we know we can find the mass of this copper sulfate that has no water. And the word for an ionic compound that has no water is anhydrous, without water. So here's the mass of the hydrate, the copper sulfate with the waters attached, and here's the mass of the anhydrous compound. If I know the mass of both of these, can I subtract them to get the mass of just the water? Here's the mass of the copper sulfate with the water, and here's without the water. If I subtract them, can I get the mass of the water? Sure. And that's why we do this lab, to figure out that mass. Now let's go look at the calculations, and I'm going to go to the sheet. So here's a problem on the second page of that worksheet. It says calculating the number of waters in a hydrate. So it says the residue of a 3.6 grams remains from. So they started out with 4.76 grams of a hydrate, and the residue, what was left over, was 3.6 grams. And it's calcium chloride. And they want us to find the name and the formula of the hydrate. Well, that's exactly what the lab asks you to do. So let's figure it out together. So we find the mass of the water. The hydrate was 4.76. And the residue, the remaining anhydrous compound, was 3.6. So I subtract them, and I get the mass of the water. So that means the calcium chloride, the dry anhydrous stuff, was 3.6. The mass of the waters was 1.6. I divide each of these numbers by the molar mass, and I don't round because I'm going to do the whole number ratio trick, so I don't round. And so this is how many moles I have of each. Again, I look at both numbers, and I look to see. I do the whole number ratio trick. I look to see which number is smaller. This one is smaller. I divide both by the smaller of the two numbers. So I divide this number by itself, I get a 1. I divide this number by that number, and I get a 1.9, so that's a 2. And so that means the ratio is 1 calcium chloride for every 2 waters. I know that I'm right if I get the ionic compound in the front always has to be a 1, and the second one has to be a larger number. It can be 1 or a larger number, but the ionic anhydrous compound part has to be a 1. Okay? And that's how you do the math for this. It's pretty simple. Okay, but I want you to run 3 trials and do the calculations 3 times and submit your answers. That's what this lab is about.